Hi everybody, welcome back to Chem 140. Oh, that was a good time for me to, oops, hold on. There we go. That was a good time for the music to fade out there. Uh, Goodness. Okay, so before we get started, in fact, let me just put this back on the title card here. Um, so you're looking at the bottom of the screen, which is important. Let's talk about things that are coming up, because week 3 is the first week that things are due. And of those things, the first one is quiz number 1. So the due date was yesterday. But remember, you get an extra 24 hours just in case you had like an emergency that pushed it off of like your mind. So if you have not done quiz number 1, make sure you do it by tonight. It will close. I don't unlock it for extra time for pretty much any reason other than like a really good one. And don't test that theory because you'll get denied. So please get that in by the deadline. Lab worksheet number 1 is due Wednesday. That's tomorrow. So make sure you also have been working on that. I have not seen very many people talking about it in the Discord, so I assume that everybody is doing okay. If you have questions of other students like, hey, what color was this thing? Make sure you're asking them. The only one who can't tell you what colors things are is me. But you can discuss whatever you want to in the Discord. Otherwise, I will just chat about random games with the other 2 students at 2 a.m. And that's kind of, it's not a lame use of the channel, but I mean, the channel is for you guys, so. Apologies for yesterday. On Sunday night, if you have not checked your email or were in the class Discord, on Sunday night, my power kind of went out. It was really, really like flickery, and then it would cut out for a short while, and then it just cut out completely to half my apartment. So I went to the fuse box thinking, oh, maybe a fuse like tripped or something. No, the entire breaker box like basically shorted out. And my apartment was at risk of electrical fire. So at 3 a.m., I called emergency maintenance and said, get out here, please fix this. I don't want to lose all of my stuff. So somebody came over at 3:30 and replaced part of the breaker box, the little thing that you toggle the fuses on and off. And I now have electricity in my bedroom. But yeah, that was my weekend. So I did not like have confirmation that like the whole thing would be done because they had to come by and like they had to change something with the dryer breaker. He didn't have one, so he had to come by later that day. So I was like, okay, I'm just going to cancel class. Because if they come by during that and they have to turn off all my power, I'm kind of screwed. So, but that's all done. Everything seems to be good. I mean, I have not had flickering power at all. Now I'm looking at the light and I'm like, don't you dare. But everything seems okay. So, yeah, I guess breaker boxes go out every 50 years or so, and just so happens to be time for this one. Or 40 years, I guess it would be, but whatever. After your grades come out for the quiz, how will you go about asking any questions? You just ask me. Once the quiz is released, I can answer any question you want about the quiz. So you can post it in Discord. You can send me an email. You can send me a private message on Discord. However you want to go about that. Keep in mind that you don't want to like accidentally release anything you don't want to. So if you're like print screening something from your quiz, make sure you aren't accidentally capturing your score if you don't want that released, or your name, or etc. Because once you put it on the internet, it's open to everybody basically. Okay, so now we can go over here. That's all my catch-up story. So yeah, apologies for having to cancel lecture yesterday, but like there were just too many unknowns with my electrical situation. But everything seems to be all right. So we're gonna do lecture today, and we're gonna do tomorrow instead of a review session and Q&A. We're gonna do the second lecture, so that we aren't super behind. And if we have any extra time, then we'll do Q&A. So for today, we're going to build upon all the dimensional analysis stuff that we did last week. And I've been getting a lot of questions about this through email and stuff, just like, hey, I did this problem, is this right, or whatever. So it's good that people are practicing that, because now we're going to do the problems that are very obviously the harder problems on the worksheet. So, like, there are very simple dimensional analysis conversions that you can do, like convert feet to miles. We're going to work up to harder problems and then also story problems. Everybody hates story problems. Nobody wants to hear a story in their chemistry problem. Bad news. Every problem in chemistry is a story problem because story problems are real world context problems is a better way to explain them. You do not ever get a problem that's like, I walked 5 miles to the store and then turned left and walked 2 miles to the bus stop. Solve for X. Like, you don't ever see something like that. It's all contextual, right? So we're going to start working on problems in the upcoming section today that are contextual nature, and you're going to have to figure out what's important based on the information provided. Now, we're going to start with just more complex dimensional analysis. This isn't a difficult problem to do, but there are more steps involved. So we'll start here, and then we'll move on to more complex story problems. All right. So on the screen, we have here a bullet moves at 750 meters per second. So let's write that down here. Can I write anywhere? Yeah, okay. So meters per second. Now remember, we don't want to write our numbers like that. Instead, we want to write them like that so that we can do dimensional analysis, right? What is the speed in miles per hour? So my goal is to get to miles per hour. And so you could see all the units on the top and all the units on the bottom should transform into one another, right? So this meters here is going to eventually become miles. And the seconds is eventually going to become hours, right? Now, how do we get from one to the other? Well, from meters to miles, I can do meters turns into kilometers, which turns into miles, because I don't remember where that conversion factor is for meters to miles, but I know the kilometers to miles one. So we'll look that one up. And then we can always do seconds to minutes to hours. That's easy enough, right? So what I'm going to do here, let's start by looking at all of these things. Let's write down all these conversions, actually. So in order to go from meters to kilometers, that would be that, yeah? Because I got the 1,000 and the K on different sides. And then to go from kilometers to miles, I believe, oops, it's that. Now that I've said that, I'm doubting myself, so I'm going to look that up. 1 mile to kilometers. 1.609344, yeah, okay. And then we know that there are 60 seconds in a minute and 60 seconds in an hour. No problem, right? So with all of those conversions here, we can do dimensional analysis. We just need to make all the units match up, because these are the units that I want at the end, yeah? So let's do that. So I don't want this meter here. This meter's got to go, so I got to put this down here to cancel it, right? And we're going to turn meters into kilometers, and then turn kilometers into miles. So we'll just do all that at once, right? There we go. So now I got the miles part done. That's all set. So now that my units are all set up, I can just plug in the numbers. So 1 kilometer is 1,000 meters. And then 1 mile is 1.609 kilometers. So this part's all done. We're all set there. Okay, let's do the seconds part. Now, the seconds is on the bottom here. I don't want it. If I put it on the bottom, they would multiply together, so that's no good. We gotta put it up here, yeah? So now those cancel. We're gonna turn seconds into minutes. And then we'll turn minutes into hours. And those minutes cancel too. And now that we've done all that, we can just plug in all the numbers again. So 60 seconds per minute, 60 minutes per hour. And so now the units that we want are what are left over, and we're all set. We can do the calculation. And I got to find my calculator. Where is it? There it is. So dimensional analysis really is just the act of, set up all your units, then do the numbers. As long as your units cancel out in the right way, you'll always get the problem correct. Now, the last thing that can happen here is when you're punching all this in the calculator, if you don't use enough parentheses, you could hit an issue. So make sure you put parentheses around all the things you multiply at the top and all the things you multiply on the bottom, and then put a division bar between them. And so when I did this, I got 1678.06. And then the last check is, well, how many sig figs do we get to use? Well, if we look at this number, is something moving exactly 750 meters per second? Probably not. That's something we would measure. We would measure that distance in a second with a ruler, so it couldn't be exact. So this must be 2 sig figs. This is exact. This is approximate. And then these are exact too. And then all the ones are exact, so we just not worry about them. So my answer should have 2 sig figs, which means that I would report it as 1,700 miles per hour. That's pretty freaking fast, right? Don't drive that speed. That would be bad. Sorry, my cat is in the background just yowling her head off at me because I'm not talking to her at the moment because I'm trying to do my job. Oh, did she run away? She heard me talking about her. Okay, I'll leave. All right, so now that you've seen me do that, I want you to do that with the speed of light. Now, this is the speed of light. It's just a bigger number. I want you to tell me this speed in miles per hour. So you're going to do literally the exact same problem we just did. But you're going to be starting with a different number. So I want you to tell me its speed in miles per hour. And then what I want you to do is I want you to tell me its speed in this weird unit, furlongs per fortnight, where a furlong is 1/8 of a mile, and that's exact. And a fortnight is 14 days, and that's also exact. So once you've got it in miles per hour, do the conversion to furlongs per fortnight and tell me what that is in the chat. So I'm going to give you about 5 or 6 minutes while I address what Princess Cat here is screaming about. And then we'll come back to go over the answers together in just a bit. So I'll see you in a second. I'm going to give 2 more minutes, and then we'll go over the answers here. Do put your answers in the chat so we can compare them. And if you aren't sure if you have the right answer, double check your parentheses. That's the most common place to make a mistake. All right. Oops, that didn't capture right. Oh, I bumped that. You know what we'll do. We'll just do that. There we go. All right. So we have the speed of light in 3 is 3.00 times 10 to the 8 meters per second. That is not an exact number. That is measured. Just FYI. And I left up all the conversions from the previous problem because, again, this is the same problem, so we're going to do the same thing. We're going to convert meters into miles, and we're going to convert seconds into hours. So we'll do that. So, where's my cursor? There it is. So I don't want meters up here, so I got to cancel it out. We'll turn that into kilometers. And then I will turn kilometers into miles. And then we'll just fill in the numbers. 1 kilometer is 1,000 meters. 1 mile is 1.609 kilometers. So that would be how many miles per second, but we don't want per second. We want per hour. So let's get rid of seconds by putting the units opposite each other so they cancel. Remember, you can multiply them in any order you want to. So it doesn't matter if they're next to each other or not. They still cancel. And then we'll do the same thing here to get rid of minutes. And then we'll fill in those numbers too. 60 seconds in a minute, 60 minutes in an hour. And then those are the only 2 units that I have left, so those are the units of my answer. And we'll punch it all in the calculator, so... make sure your calculator's on. That's probably the first thing. Make sure that you know how to type in exponents into your calculator. So you may have buttoned this as E on it. Like capital E, not lowercase e. Lowercase e is a number. Capital E is the exponential notation indicator. Make sure you know how that works. Yours might say times 10 to the n or things like that. If you aren't sure how your calculator functions, take a picture of it and post it in the Discord, either in a private message or whatever, and I can help you find it. I have seen every calculator under the sun. Turns out there's only like 20 different calculators out there, and I've seen all of them. So if you don't know how to interpret what yours is saying, let me know and I can help you. I should be typing in numbers while I'm talking about that, but there we go. So I got 671224363. That's not super helpful. So we're going to make that into scientific notation. 6.71 times 10 to the 8 miles per hour is what I got. And then we'll check for sig figs. So this is 3 sig figs. And then just like before, that's exact 4 sig figs. And I don't know why I was writing sig figs here. These are exact. So our answer should have 3 sig figs. And that makes sense because the previous problem, when we went from meters per second to miles per hour, we basically multiplied it by 2 a little bit, right? So our answer is more or less doubled. Oops, hold on. I'm covered up the chat here. Can you break down doing the numbers? Sure. So what I'm doing is once I've got the units put in the right spot, I'm basically putting the conversions into the spots where they belong. Can I show you Wolfram Alpha? Yeah. So this 1,000 meters equals 1 kilometer, I put in this spot. Here's where I put this one. I'm going to have like arrows going all over the place here, but that's okay. And then here's where 60 seconds is a minute and 60 seconds. Oh, oops, hold on. I wrote the wrong thing here, but probably didn't notice it because nobody mentioned it previously. So they're not 60 seconds in an hour, otherwise class would have ended a long time ago. But that's okay. If you didn't use scientific notation, that's fine. You could just put a bunch of zeros. Make sure you have the correct number of sig figs, though. So that's what it looks like from our conversions. We're just taking... In fact, you know what I could do? So this... Oops, that's not what I want. That's not at all what I want. Do I have the wrong thing selected or something? Oh, Photoshop, why are you like this? There we go. So this conversion right here is this right there. And then this one right here, I have no idea if this is helpful or just making it more of a mess. This is this one right here. And then let me just tidy up real quick. And then the other two are right above where they need to be. So, all right, hopefully that helped. Now, if you're going to do this in Wolfram Alpha, let me get Wolfram Alpha open real quick. Oh, I can't have it on this monitor because I need that to be able to see it over here. So, add window capture, Wolfram Alpha. Okay. We don't need to see what's on my browser bar. And we really don't need to see much more than that. So we'll make that bigger. And so if I was going to type in these numbers, which I can no longer see, so give me a second to tinker here real fast. Now I can put this over here. So here's what I would type in. So I would type parentheses 3 times 10 to the 8. Oops. Times 1 times 1 times 60 times 60, not 69. Divided by 1,000, which is 10 to the 3, times 1.609. And so that's what I would get. 6.71 times 10 to the 8. Although this notation... Oh, you might not even be able to see that. I'm not sure if it's popping up the little drop-down menus. Let me just hit enter. There you go. So you should be able to see what I see. Oh, maybe not because I cropped it a little bit too much. There you go. Now, Wolfram Alpha is going to give you every sig fig under the sun. But just keep as many as you need, which is not 74, or however many digits that is. Ooh, we could get more digits. How many more digits can we get? Oh, that's too many digits. Fewer, please. Thank you. All right. All right, so that's how I would do that in Wolfram Alpha. All right. For the next one, let's get rid of that because we're going to come back to it, I think. Now we got to do furlongs per fortnight. Now you've already gotten the answer in miles per hour, and that's particularly useful for this problem because going from miles to furlongs is pretty trivial. So we're just going to take our answer from up here, put it down here, and we'll just keep doing the problem here. That's not the right number. So this is miles per hour. No problem. Now we're going to do this in furlongs per fortnight. So let's get rid of the miles part first. Because we know we can go directly from miles to furlongs, which I'm going to abbreviate furl. And then we'll just do the numbers. 1 furlong is 0.125 miles, according to the PowerPoint that's at the top of the screen right there. So now we know furlongs per hour, but I want furlongs per fortnight. Fortnights are going to be a little bit more difficult, right? Because I got to go from hours to something to get to fortnight. Well, I know how many days there are in a fortnight. And I know how many hours there are in a day, so there we go. I put way too much space in there. This problem is suddenly even more relevant because there is a game called Fortnite. They just spell it incorrectly in their game. So now I'm going to say, okay, I don't want hours in here, so these can cancel out if I do that. We'll turn that into days here. And then we'll cancel out days and put fortnight. And so now we just have to fill in the numbers. Well, how many hours are in a day? Well, we all know that, right? And then how many days are in a fortnight? According to the slide there are 14 days per fortnight. Oh, I need just a second. Sorry, cats are fighting. That literally was just me turning around yelling, "Stop fighting." but I muted it anyway. If I hear them again, though, I might have to go and attend to that. So what units do I have left over? So I have furlongs per fortnight. Now, I don't know how to abbreviate these, so that's just what I've chosen to do. And I'm going to punch that all in the calculator, and we might as well go back to Wolfram Alpha here. So we'll put that back on the screen, and we'll go... So 6.71. Oh, it does show you what's popping up. So that's the number we just did. That's actually not going to help me if I do it that way. Times 10 to the 8 times, and I need to move this because I can't see it, 24 times 14, and I forgot to put parentheses around all this. So let's do that. Divided by 0.125. You don't need these parentheses, but I'm just doing it out of an abundance of caution. And then the answer that I get should be this right here, which when I hit enter. And they didn't give it to me in scientific notation, but it should be 1.8 times 10 to the 12. 1.80. So we'll write that down. 1.80 times 10 to the 12 furlongs per fortnight. There you go. So we've done a more complicated problem. Oh, again, you can't see that because of how I have it cropped. But there's the answer. And then there's my answer right there. So we've done a more complicated problem using basic conversions. So in the next section, what we're going to do is we're going to develop this a little bit further. And we're going to, instead of using conversions that we can look up, so like we looked up how many meters are in how many kilometers are in a mile. Or we could have looked up how many furlongs there are in a mile, or how many days there are in a fortnight. Those are all things that exist online. But for problems that involve more contextual circumstances, like whatever the current price of aluminum is, that's going to be context specific. You're going to have to find that information in the problem that you are working on. And so you're going to get conversions that are unique. Oh, I forgot about this slide. So we're going to do this first too. What happens if you have cubed stuff? There were some questions about this over Discord. And maybe it wasn't Discord. Maybe it's just the Q&A on Wednesday last week. What do you do when you have like a squared or a cubed unit or something like that? Well, we know that this is a factor that exists. You know how many inches are in how many centimeters because you could look that up. But how many cubic centimeters are in how many cubic inches? Well, what we can do is if I want to get the cubed version of this, I just cube everything, right? Because if I multiply both sides by 3, then I would have everything tripled, right? So if I just cube both sides, it's the same thing. You could, as long as you do something to both sides, it's algebraically correct, yeah? I could take sine of both sides, or I could square root both sides. So sure, I could cube stuff. But what we have to do is we have to make sure we cube it correctly. So when you cube something, or square it or whatever, you have to cube all the parts. Cube one, cube all, right? So this conversion would then become 1 cubed inches cubed equals 2.540 cubed centimeters cubed. And then we could just do the math here, right? So 1 cubed is 1. And then 2.540 cubed, we'll punch that in the calculator. I think it's 16.9. 16.4 is what my calculator says. Although it's not in scientific notation mode anymore. Yeah, 16.4. There you go. So all my text is going to appear on top of stuff here. Oh, I didn't write down enough sig figs there, so since this has 4 digits, this should have 4 digits too. Now, technically speaking, this conversion is kind of unusual. It turns out that there are exactly 2.540 centimeters in a cubic inch. Or I'm sorry, 2.540 centimeters in a regular inch as a definition. But I would not fault you for not knowing that. Oh, good. You got your calculation fixed. That's good. So if you need to make a conversion, you just cube stuff or square it, or you do whatever you want to. Now, sometimes I may give you a one-dimensional unit only, or you may only know of the one-dimensional unit in like a data table or on Google or whatever. So just square or cube or whatever both sides and you'll be fine. So let's do an example here. So I have a can of polar seltzer. I was trying to say soda, I think. Or I've suddenly become New Joysian or something. I'm not from New Jersey. I'm from California, believe it or not. The can of polar seltzer that I have is 355 milliliters. What is that in cubic centimeters and cubic inches? Now, this first part here is actually kind of a memory check. So, if I write this out... Yeah, that's what I think I was doing. I was reading soda on the screen, but looking at the can of seltzer, and I just sort of put both of them together. Anybody remember the conversion between milliliters and cubic centimeters? If not, you have to look it up every time, but there's a very simple conversion for this. Anyone remember it? Yeah, it's just one, right? Yeah, there you go. They're the same thing. So if I do this, this seems like a colossal waste of time to do. But the reason that I'm writing it out is just to show where the units go. Because 355 times 1 divided by 1 is the same thing, yeah. So if you're looking at your seltzer can and going, oh, there's its volume in milliliters, that's also its volume in cubic centimeters. Now, how do I do that in cubic inches? Well, I got to set up the centimeters to cancel out, but I need a cubed, right? And I don't know the conversion from centimeters cubed to inches cubed. So I'm going to write it like this so that the units will cancel out. And then now in the parentheses, I'm going to put the one-dimensional unit as shown, because that's what I have, right? I have inches and centimeters. So we'll write that. 1 inch is 2.540 centimeters. And then I'll just cube everything when I do the calculation. And so let's show how that works. We'll get Wolfram Alpha back out here. If I can find it, where did it go? Is it on this screen? Oh, it's over here. Okay. Let's see here. Oh, it lost Wolfram Alpha because I minimized it or something. There we go. And now it's this size. Oh, no, I'm just on a different window. That's what's going on. All right, so we got 355 times 1 cubed is 1, divided by 2.540 cubed. And they say 21.663, which for 3 sig figs would be 21.7. That's the wrong unit. Hold on. No. Not laser. Ooh, I can point at stuff with the laser. Ooh, that's not a useful tool to me. There we go. Inches cubed is useful if you are a mechanic that works on Harleys, or I guess American engines, because the displacement of an engine is always measured in cubic inches for some reason. But for this purposes of this class, we're going to use milliliters and cubic centimeters, and of those, we're going to use milliliters. So, all right, so that's how we use squared and cubed units in calculations. Write down the one-dimensional unit, and then just do whatever power you need to. All right. I'm clicked on the wrong window, so nothing's happening there. So let me clear out all this so that you can read that if you need to. All right. I'm going to show you this next problem because you're going to see questions on the quiz that are similar to this. So this is what I call a, hey, you can't Google this problem because these units don't exist. I made this up. So you're going to see a problem on the quiz that has fictitious units that are completely garbo, but I give you the conversions there. So you do have to do the problem. Now, this problem makes no sense until you read it very carefully. So on a distant planet, we have volume. I'm not on the right screen, am I? There we go. We have volume, and volume is measured in Zorgs and cubic blargs, and length is measured in blargs. So that tells you right there, something that I have underlined is a one-dimensional unit, something is a three-dimensional unit, and something is a one-dimensional unit made into a three-dimensional unit. Okay? Hopefully that made sense. You can tell the dimensionality of the units based on their context, because that's going to be important. So I'm going to give you a cup of tea, and the volume of the cup of tea is this number. So I want you to turn it into this unit, into cubic blargs, and then into cubic inches using these conversions I provided for you. And then the last question that I have, oops, I guess we should say size, is this is a contextual question also. When you get your answer at the end, I want you to try and tell me what size creature would consume this. Would this be something that an elephant would drink? An ant? Your aunt? Your Aunt Susan? I don't know. Something like that. How big is this relative to, like, a volume that something would drink? So think about that and then type what you think that is in the chat once you have also gotten the number answers for this. I'm going to give you a few minutes to solve this, and then we'll go over the answers together in a little bit. How are you doing? Once you have your answers, type them in the chat. We'll go over the answers together in just a second. All right, 1 or 2 more minutes. We'll go over the answers together. And then we'll be due for a break. All right, so let's... First, I got to clear this. All right, so... Oops, that didn't do anything. There we go. Where did I put the stylus? There it is. All right, so I have a cup of tea. Oops, I got to scroll up here. That has this volume. And I know that there is a conversion for 1 Cg equals 32.5 Bg cubed. So I could do dimensional analysis. And remember, the whole point of dimensional analysis is just cancel out the units, right? So you can just do that and that. And then I'll just match up the numbers. One of those is 32.5. Well, not 3.25. Of those. And so that will give us the volume in cubic blargs, which is this weird unit that I have just made up. 4,940 of those. So that's the first answer. Now we got to turn that into cubic inches. So we'll start by taking this number. And I need to get to cubic inches as my answer. But all I have is a one-dimensional conversion. Well, if I write that down here, and then cube it, then it will cancel. So we'll put the one-dimensional conversion in the parentheses right here. So 1 inch, 15.5 blocks. And then we'll just cube one cube all, right? So when I type this into Wolfram Alpha, I would type in... I gotta find it again. Hold on. Window capture. Oh, you already captured it. Okay, cool. Boop. All right, so we will type in 4940 times 1 cubed, which is 1. So divided by instead, actually. 15.5 cubed. And we'll put that in parentheses. And I get 1.32 is what it says. All right, so let me minimize that. Let's get this out of the way. All right, have we guessed what size creature would drink 1.32 milliliters of stuff? Oops, I hit the wrong button. Hold on. All right, hopefully you guessed Roadhog because that was correct. Well done. All right, that's all we got for now. We're going to take our 10-minute break here. So we'll... Oops, that's the wrong thing. We can turn Roadhog off now. And I don't have a timer up, so let's put that on the screen. Did it appear? It did appear. Okay, cool. So I'm going to go hit the music. We'll have more Stardew Valley. And we'll come back in about 10 minutes. And I'll see you then. Alright, we're back. I just wind the music down here. Alright, so now that we have seen conversion problems using 3-dimensional units, 1-dimensional units, any dimension we want, and fictional units, I didn't mean to minimize everything here. Hold on. There we go. I need that on the screen so I can see you guys. See your chat, I mean. I don't have a camera of any sort. Now that we have examined those types of units, let's look at conversion problems where we could construct a conversion out of pretty much anything. So these types of problems will require us to look at the context of what the problem is asking to derive the conversion. Now, they aren't any more difficult in terms of solving. The trick to these problems comes in deciphering what the problem is trying to ask you. So your objective for story-type problems like this is to try and figure out, okay, what's the goal of the problem and what conversion in the problem gets me there? And the key word that you're going to look for, which is in almost every problem, but not all of them, is the word per. Because whenever you see the word per, you could substitute that with a division bar. So if I'm going 5 miles per hour, that's how fast I walk, I guess. That would be 5 miles per hour, or 5 miles / hour, right? So we could use that as a conversion. Likewise, if I drink 6 cans of polar seltzer a day, they don't pay me to do this. I just like it that much. That would be 6 cans / day. Or maybe my cat harasses me every 40 seconds. So I would say 1 cat per 40 seconds, or something like that. So here's a practice problem that we're going to solve together. So if a person eats 2 pounds of food per day, which is a lot of food, it turns out, how much food will this person consume in 85 years? Now, this is assuming that they eat 2 pounds of food per day every single day, including the first day they were born, which would be quite disgusting. And even if they were 85 and eating 2 pounds of food, I would be concerned about their health and well-being. But the point is, we can use this information to solve the problem. It may not be a very good problem, but, you know, whatever, right? I'm not on the right screen. There we go. I'm on the right screen now. So if this is what the problem is written, 2 pounds per day, I can rate that like this. 2 pounds is equal to 1 day, right? So if I know how many days the person has consumed food, I would know how many pounds they've consumed. Well, I've given you the quantity 85 years. And I know that years is an amount of time, right? So is days. Not tame, time. You know, we'll just pretend that didn't happen. So if I can convert this time to this time, I can then get the weight of food. So let's do that. We can go years to days, very trivially, by just looking up how many days there are in a year. Well, is it leap year or is it not leap year? It depends on what the year is, so we're just going to take the average here, right? So I'm going to say that there are 365 and a quarter days per year. And then these units would cancel out, and now I have days. So now that I have days, I can then convert to pounds. Now, if you did 365, that's totally close enough. In any problem that the leap day would matter, I will tell you that 365.25 days are in 1 year, so that you don't have to look that up. Generally speaking, though, since you don't know what year the leap year is, and in 85 years, you're going to hit a bunch of leap years, right? So we would include that. And then now we've got days canceling to give us pounds, and we know that this person consumes 2 pounds per day. So we would just punch all the numbers into the calculator. And in this circumstance, we're just multiplying everything together, but that's not always the case. So 62,000 pounds of food is what I calculate for this person to consume in 85 years. Gross, right? But no, we eat a lot of food and we actually produce a lot of waste. And people do a lot individually, believe it or not. Like, how much CO2 do you make? You'd be surprised over the course of a long time. Like, I try not to think about that. That's too depressing. All right, so that's the first problem. I'm on the wrong screen again. That's why I'm faffing about here. So if I do that, the answer will appear. Let's get the next question here. All right. This problem is kind of outdated because this was from teaching in person years ago. So a full-time faculty member, which technically I am associate faculty, so I'm not full-time. I've been doing this for 10 years though, so I'm essentially full-time. Is paid $82.50 per hour to teach Chem 140 to a class of 24. How much money is earned for 20 2-hour lectures for this class size? Now, before you look at that and say, wow, that's so much money, Wes is making bank, false. And we'll show why. So, hold on just a second. I got to do this, and then we'll do that. There we go. So now I know where not to draw above. So we know that the faculty salary rate is $82.50 per hour, which we can then write as $82.50 is equal to 1 hour. Well, if I knew how many hours this faculty member was teaching, I would just times it by 82.50 and that would be how much money they get. But I know that they have 20 lectures because it says that in the problem right here. Now, this problem doesn't actually have the word per in it, but from the context of the problem, how many lectures are, or how many hours are there per lecture? Well, according to that, it says they are 2-hour lectures, so I would just go like this, right? So how many hours is this instructor teaching? They're teaching 40 hours worth. And then now I can just use this conversion. And we learned that this is why America undervalues its instruction. It doesn't pay faculty shit, right? So for a 3-month job, I would get $3,300. That would not pay my rent for 3 months, for what it's worth. So despite that looking like, wow, that's a lot of money. Yeah, it would be if I did all 40 of those hours in a week. But I don't. I do them over 10 weeks, right? The other hours where like I talk to you guys on Discord or I answer email or I grade your assignments, I am paid $0 per hour to do that. I'm required to do it, but I'm paid $0 an hour to do it. So, fight for faculty and fair pay. If you see like news about that and teachers going on strike and stuff, support teachers because we don't make enough money. Nobody does this job because they imagine that they are going to be wealthy. I do it because I love it. I love this. I love teaching, but it would be nice to be able to afford things, right? So if you're wondering how the heck does Wes survive on so little money, the answer is I get paid more because I teach multiple classes. So I'm actually teaching 48 students for this class, so that would be doubled, and also that isn't counting lab, which I'm also paid for too. So like there are other factors, but I guess the takeaway is when you see this, oops, now you don't see it at all. When you see a big number like this, don't suddenly go, wow, that's so much money. Like, look at the context of the problem. Oh, I got to go back to the this screen. Okay. So I'm going to give you some problems here for you to try. Oops. So the first problem, this was the cost of aluminum when I wrote this problem. Aluminum has skyrocketed in price, so I don't think that that's accurate anymore. Let's assume that aluminum costs $0.9317 per pound. Now, you may have wondered, why the hell do you need those decimals after the hundreds place for pennies, right? And the answer is, well, if you buy a lot of it, those numbers matter. For instance, gasoline is sold to you with a thousandths place cents digit. And so you can actually see that. You go to the gas station and it's like gas is currently $4.129 per gallon. And you might think, well, why does that 9 matter? It matters if you bought a ton of gallons, because eventually that penny or that 0.9 would carry over. Most of the time it doesn't matter and it's just rounded off. But if you buy tens of thousands of gallons, like the people who buy the gasoline and put it dispense it do, that number matters. So, using that price per pound, what's the cost of 1 metric ton of aluminum? Now, 1 metric ton is exactly 1,000 kilograms, but note here that this 1 that I have written is a measured quantity. So, this 1.000 has 4 sig figs, so just be mindful of that. And then for problem 2, blood has about 1.52 grams of sodium per pint. How much sodium is in your bloodstream if you have 10 pints of blood? Give that conversion or the amount of sodium in pounds. Now, if you don't know a conversion, look it up on Google. You can type in any conversion you want, and it should give you that information. But you'll need to use that information to solve this in some way. So do the dimensional analysis, type your answer in the chat, and we'll go over the answers together in about 5 minutes. That's actually a lot cheaper than I expected aluminum to be. I thought it was like $2. I mean, the pandemic has made everything more expensive. Don't even get me started on video cards. All right, one more minute. We'll go over the answers together. If you have an answer, though, let me know in the chat. All right, so just clearing off my, oops, hold on. My Photoshop here. Boop. All right, so let's look at this first problem here. So we know that aluminum costs $0.9317 per pound. So I can write that conversion. And I want 1 metric ton of aluminum. I don't know what to abbreviate that as, so I just wrote that M ton. Well, I know that 1 metric ton is 1,000 kilograms. Because I gave you that number. So we can immediately make that conversion. So metric ton to kilograms. And then we'll just do the numbers real quick. So 1,000 per metric ton. And then I need to get to pounds somehow, because that's what my money conversion is in. But I have kilograms, so I'm going to go look up the conversion from kilograms to pounds. And I've already done that. 2.205 pounds per kilogram. And then finally, for every pound I have, the cost would be 93.17 cents, I guess. $0.9317 per pound. And so he just times all those together. And I got $2,054.39, which we're going to round to 4 sig figs because this number right here is 4 sig figs. This is exact. And these are both 4 sig figs. All right, so that's the first problem. That's how much it costs for a ton of aluminum. $2,000. So if you drink as much seltzer water as I do, keep those cans, I guess? I don't know. I just take them to the recycling center and like, here you go. What am I doing? I'm doing this. There we go. All right, let me just move this up a bit. There we go. All right, according to this right here, blood has about 1.52 grams of sodium per pint. How many pounds of sodium are in the human bloodstream with 10 pints of blood? So let's find that out. So I'm going to have 10 pints of blood. Well, if I know how many pints there are, I know how many grams of sodium are in there. So I can do that conversion right away. If you're wondering what Na is, that's sodium. We're going to talk about that next week when we start with the periodic table. And then I can do the numbers. Now I have grams of sodium. I need to turn that into pounds of sodium. And I can look up the number of grams per pound, and it's something like this. So you'll notice that, hey, sometimes we actually do divide by numbers here. Don't just multiply all the numbers that you're given together. It doesn't always work. And so I get 0.0335 pounds of salt, or sodium, which is just one part of the salt, to be fair. So you can spam that salt emote now. All right. All right, that is it for dimensional analysis. We have exhausted all the problems that I have for that. There are tons of problems in the worksheets and the practice workbook and also in the online text. Your goal is to do as many of those as possible until you get to the point where you're like, ugh, these are so boring. I could do them in my sleep. And then you'll be perfectly prepared for quiz number 2. But before we get to quiz number 2, we got to talk about percentage, because percentage is the last part of Unit 3. Percentage is also a dimensional analysis unit, but it's a little bit different because it comes from a formula. Now, you probably know how to do percentage. Percentage is just the number of items of interest divided by the total number of items in the set that you are examining times 100%. Now, this part right here can be expressed as a conversion. And we're going to show a few problems that use that. But for now, we're going to stick with just the simple formula. So for instance, let's suppose that in 1/4 that I taught Chem 140, 37 out of 45 people got a passing grade. What percentage of students pass the class? Well, I would say, okay, the number of interest items would be pass the students that pass, and the number of total items would be the total number of students. So I would write 37 of 45 times 100%. And I get 82%. Now, technically, I would get 82.222 forever, because these are exact numbers. And in fact, these are... I should write people, but that's just going to cancel out anyway. So percentage is quite straightforward. You've probably used this before. Now, if it shows up as a conversion factor, though, that can have a useful application in doing other calculations like the ones we've been doing. For instance, let's suppose that you're working with steel in like a metallurgy class or something, I don't know. And you are told that the alloy you're working with is 94% iron by mass. What would the mass of iron be in a 5 kilogram steel alloy bar with that make or composition? Now you would say, oh, I'm just going to take 5 times 0.94. And you'd be right. But the reason that that works is the following. If I have 5 kilograms steel, and I know that it's 94% iron by mass, that's the same as me saying the following. For every 100 kilograms of steel, 94 of those are iron, right? Because that's what percentage is. And so I'm going to put that instead right here. With the units set up so that they cancel out. Now, if I had to, I could flip these. Because the ratio would still be true. And then I would say for every 100 kilograms of steel, 94 of them are iron. So there's your times 0.94 that you're familiar with. Oops. And so I get... Oops, this should be 5.0, sorry. So now I have two sig figs. So now I get 4.7. All right, let's do another one here. Air is 21% oxygen by volume. If I have 1.25 liters of air, how many of those milliliters are oxygen? So again, this right here, if it's 21% oxygen by volume, that's saying in 100 liters of air, 25 of those liters, oops, not 25, 21 of those would be oxygen. Okay, well, I have 1.25 liters of air, according to this problem. How much is oxygen? Okay, well, we'll use that conversion that we just got right here. Liters of air, liters of oxygen. And then I have to convert to milliliters because that's what the question is asking me to do. Well, we can do that easily enough. Because we have all that metric stuff that we've been doing forever. And you just punch in the calculator. And you get 263 milliliters of oxygen, which if you're playing Outer Wilds right now because the expansion came out, that's about how much it feels like is in your air tank when it's constantly depleting. Thankfully, the area is full of trees. Trees detected. Oxygen tank refilled. Hooray. All right, let me know if you have any questions about it. Let me clear this real quick so that you can see all the text. I'm going to give you your practice problems for this section. So the first question is just a regular percentage problem. So when I was looking up stuff for this slide, I was trying to find like a Scrabble dictionary, and I think the most recent one I could find at the time was 2015. In the Scrabble dictionary for 2015, 277,663 words were allowed. This space is just because I was separating out numbers. There should be a comma there. Of those, 5,846 contained exactly 4 letters. What percentage of words that you can play in Scrabble do not, and that's the key word, do not contain 4 letters? And then for problem 2, trimix is a mixture of gases that we use for deep sea scuba diving. And it is a mixture of oxygen, nitrogen, and helium. I give you a composition on the board there. I want you to tell me the volume of each gas at that composition in a 12-liter scuba tank. Okay? I'll give you 5 minutes to look at that. We'll go over the answers, and then we'll be done. We'll get to percent error tomorrow. We're more or less done with Unit 3, though, so I'll be back in 5 minutes. We'll see you then. One more minute and we'll go over the answer. All right, I need to rearrange the screen, so we'll do... Let's do that. Oops. Clear all. And I keep putting my stylus in the wrong spot. Okay. So I have 277,663 total words that I can play in Scrabble. And of those, 5,846 are 4 letters. So if I want the ones that are not 4 letters, I would subtract 7, 1, 5, 8, 7. A wise person would have just used their calculator, I guess. Is that right? Now I'm going to just go to use my calculator anyway, because why did I... 271817. See, I didn't trust myself, and for good reason. So there are that many words that do not have 4 letters in them. And the question is asking, what percentage of playable words do not contain 4 letters? So the percentage would be words that are not 4-letter over the total words times 100%. And so that would be 271,817 divided by 277,663. And that number is 97.9%. Well, given that these are all counted, we would keep as many sig figs as we wanted to here. So, whatever. I'm just going to write it with 4 sig figs. All right, so there's the first one. Let me get this out of the way there. All right. And then we have our compositions for our gases. So let's do oxygen first. So this will be my oxygen. So I have 12 liters of air, or of trimix, I guess I should say. And I have 21% oxygen, which means that for every 100 liters of mix that I have, I guess I should call this mix, 21 of those liters would be oxygen. And so the amount of oxygen in the 12-liter tank would be 12 times 21 over 100, or 2.52 liters of oxygen. And then we could do that for helium. Why is helium put in there? Is it because we want deep sea divers to sound like this? No, it's actually because helium has a very, 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 very low boiling point, and so it won't condense into a liquid. But you need pressure to actually be on your lungs so that you don't just immediately exhale all of the air inside because of the weight of the ocean. So helium is just a filler gas. A little nitrogen is put in there because it's cheap and inert, and helium is much more expensive and harder to get. But if the remainder was just nitrogen, then you would end up with a situation where you may have heard of something called the bends, which is where you have so much nitrogen that it dissolves from the gaseous phase into a liquid because it's pressurized so much, and then you have liquid nitrogen in your veins, which it's not cold at that temperature, it's just very pressurized. But as you ascend, then it starts to boil and expands, and if that happens in your veins or your arteries, that would be very bad. So we use less nitrogen to try and avoid that. So just a little bit of scuba sense, I guess we'll say. All right, so we got helium, and this is 35%. So for every 100 liters of mixture, I'd have 35 liters of helium. For a total of 4.20 liters of helium. Now, for the nitrogen, there's two ways to do this. Here's the way that we've been doing it. And we would still say, okay, whatever the mixture is. So the remainder must be nitrogen, because that's what the problem says. So you'd say 100% minus 35 minus 21, and you'd get 44. Uh-oh. Oh, I was holding a button. That's why it's not writing. There you go. And then you just solve the problem that way. 12.0 times 44 over 100. There you go. I just realized that I should be doing this based on what all the numbers are saying in the problem. So there we go. Now I definitely should have 3 sig figs for my problem. So there you go. The other way you could get this number is you could say, well, it's a 12-liter tank, right? I'm just going to subtract out the other two things. So whatever this is. And then this will be that number right there. Either way works, but you'll notice that if you do this way, then you lose the sig fig, and you would only end up with 2 sig figs. So we would get 5.3 if we did it that way. All right, so that's some experimentation with percentage. Make sure that you are proficient with how to use it, because it will show up on the quiz. All right. When we come back on Wednesday, we're going to do this last section, which is percent error. I am going to release the quiz tonight, just to have that up there. But we are essentially done with Unit 3. There's like 2 slides left, which is this stuff. I do want to thank everybody for coming out to the lecture. And I do, again, apologize for yesterday's issues with me not being able to get to the lecture. Hopefully that won't happen again. I mean, if the power breaker box screws up twice in a week, I'm just going to move. I'm going to just go somewhere else where there are hopefully not electrical problems. So tomorrow's lecture should go as planned. Look for quiz number 2, which will be Unit 3 coming up later today. And it'll be due next week. Have a wonderful evening, and I will see you next time.